Hello viewers, in today's class we are going to discuss one important definite integral, and in this integral we are going to use the method of substitution, right? So here we are given the problem, that is integral from 0 to half square root of 4x over 1 minus x dx is equal to lambda minus mu, and we have to find the value of lambda and mu, right? So now in order to solve this integral, let us first take the integral, this integral as I, and I is 0 to half, and we have square root of 4x divided by 1 minus x, right? So viewers, here what we will do, we'll make a proper substitution here, and the substitution is we can take x is equal to sine square theta, right? So we can take x equal to sine square theta. Now dx over d theta, so differentiating both sides, the derivative of x with respect to theta is 2 sine theta and cos theta, right? And dx is now equal to 2 sine theta cos theta d theta, right? So now we have the value of dx as 2 sine theta cos theta d theta, and now let us change the limits accordingly, right? So here we see that x varies from 0 to half, right? So when x is equal to 0, then sine square theta is equal to 0, right? And this implies that sine theta is 0 and theta is equal to 0, because sine 0 is equal to 0, right? And when the upper limit is half, that is x is half, then sine square theta is equal to half. So here we'll take x equal to half, and we have sine theta is equal to 1 over square root of 2, right? And theta is obviously equal to pi by 4, right? That is 45 degrees. So now when x varies from 0 to half, then theta varies from 0 to pi by 4, right? So now this integral takes the form in terms of theta. We have 0 to pi by 4, substituting the limits, and we have square root of 4x over 1 minus x. So we have 4. For x we can write sine square theta, and here in the denominator we have 1 minus sine square theta, and for dx we can write 2 sine theta cos theta, right? Okay, so now we can simply simplify this expression by making some rules from trigonometry. So 4 sine square theta is 2 sine theta, and in the denominator we have 1 minus sine square theta, and 1 minus sine square theta is equal to cos square theta, right? And the square root of 1 minus sine square theta is square root of cos square theta, that is equal to cos theta. So here we have cos theta, and 2 sine theta cos theta d theta, right? So cos theta and cos theta get cancelled, and now we have 2 times 0 to pi by 4, and 1 2 we will retain inside the integral. So we have 2 sine square theta d theta, right? So now the original integral is reduced to this form. So now in order to move further, here we'll make use of one important result from trigonometry, right? So we know that cos of 2 theta is equal to 1 minus 2 sine square theta, right? So 2 sine square theta is equal to 1 minus cos of 2 theta, right? So here we'll take this expression. So we have 2 times 0 to pi by 4, and we have 1 minus cos 2 theta and d theta, right? So now we have two terms, and the integral of 1 d theta is simply theta, and the integral of cosine 2 theta is sine 2 theta over 2, and the limits are from 0 to pi by 4. So now we can simply substitute the limits and we'll take the difference. So we have I is equal to 2 times, and here we have, first we'll take theta is equal to pi by 4 here. So we have pi by 4 minus sine 2 pi by 4. So we'll have sine pi by 2, right? And we have 2 here, and minus then we'll have theta is equal to 0, and theta is equal to 0 makes these two terms equal to 0. So we have 0 minus sine of 0 over 2, that is 0, right? And now we have 2, and this is pi by 4 minus sine pi by 2 is 1. So we have 1 over 2, this is 0, and multiplying these two terms by 2 we'll have pi by 2 minus 1, right? So the value of this integral is equal to pi by 2 minus 1, right? But in the problem we are given that this integral is equal to lambda minus mu. So if we now compare both these sides, lambda is equal to pi by 2 and mu is equal to 1, right? So viewers, this is how we find the value of lambda and mu, and this is how we use the method of substitution to solve this problem.